So we know how to take the derivative of a typical single variable function. If my f of x is just whatsoever, then the derivative is just going to be f prime of x. Or we can also write this using the f by dx, and this is going to be just the derivative of the fx that we have. Now then, if we have multi-variable functions, if we have functions of several variables, like say if I have f of x and y. Now I can also take the derivative of this guy, but because I now have more than one variable, so that means I can take derivative with respect to each of the variable, and we're gonna call this partial derivative. So the notation for partial derivative is going to be this delta f by delta x. So notice how we're gonna use delta instead of d to remind us that we are doing partial derivative here. Or we can also use x as a subscript. Notice how we are not going to use f prime anymore because this would not tell us if we are taking derivative with respect to each variable. So, when we take derivative of f with respect to x, what is going to happen is we are going to treat x as a variable. I'm going to treat this x as a variable. And I'm going to treat everything else as a constant. Everything else as a constant. And that's the same when we take derivative with respect to y. I'm going to treat y and only y as a variable, and then everything else as a constant. So let's take a look at the examples that we have down here. For the first guy, my f of xy is going to be, let's see, 2x to the 4th y cubed plus e to the x minus 5y. Now then, if I want to find the derivative of this guy with respect to with respect to x, df by dx here. So what that means is I'm going to treat x as a variable. So this x is I'm going to think of it as my variable. And my y is going to be just a constant. So I'm going to think of y as a number. So let me just change the color for the terms with x here. Okay. So if I like to take derivative with respect to x, then let's see what I'm going to get. 2 is a number, so it stays there. Y cubed, well, I'm going to treat y as a number, right? So y cubed stays the same. And the derivative of x to the 4th is going to be 4 times x cubed. So this is going to be the derivative of my first term. Notice how x to the 4th becomes 4x cubed. But because this is derivative with respect to x is the star this time, so my y cubed just stays the same. And as for the second term, e to the x, the derivative of e to the x is just going to be the same thing, e to the x. And for the last term, 5y. Now, because y is just a number, when I multiply number times 5, so this last term is just a number. The derivative of a standalone number is going to be 0. So this guy is going to be just minus 0. So here, this is my derivative with respect to x. So let's now take the derivative of f with respect to y. So let me kind of just copy and paste this. So now my y is a variable. So let me focus on the y now. So this is the term with y in it. And then we're going to have this guy. Okay. So now I'd like to take the derivative df by dy. So again here I'm going to treat y as a variable and treat x as a number. So the first term, 2x to the 4th, this is just a number multiplied to y cubed. So that number stays the same. And now the derivative of y cubed would become 3y squared. The second term, e to the x, well, e to the x, this is just a number. So the derivative of e to the x would just be 0. And for the last one, negative 5y. Well, the derivative of minus 5y is going to be just minus 5. So the derivative of the last term is going to be just minus 5. Okay, so here, this is my derivative with respect to y. Now for the last one, df by dy and the vertical bar 1, 2. So this vertical bar, it has the same meaning. It basically just means when. So this last part asks us for the derivative, for the partial derivative of the f with respect to y when my x is 1 and my y is 2. So what I'm going to have to do here is just look at the df by dy, which is this thing. And I just only have to plug in x equal to 1 and y equal to 2. So what I'm going to get, so let me actually just do it up here. So what I'm going to get when I plug in x equal to 1 and y equals to 2 is I'm going to get, let me see, 2 times 1 to the 4th times 3 times 2 squared plus 0 minus 5. And this is going to equal to, let me see, I'm going to have 8 times 3 and that's 24 minus 5 and that's 19. So here is the answer for my first example here. Now let's take a look at the second one. My function now is my f of xy. This is log of x times y plus e plus 3 to the y minus 24x. And I'd like to find the derivative of f with respect to x. Once again, I'm going to use this subscript to mean that I would like to take the derivative with respect to x. So my x is a variable and my y is a constant. So wherever there is x, I'm going to look at it as a variable now. Okay. So the derivative of log of x is going to be just 1 over x. So this guy becomes 1 over x. And y is a number multiplied to something, so that y stays there. The second term, 3 to the y, well, this is just a number because y is just a number. So this guy becomes plus 0. And the last term, negative 24. Now, the derivative of 24x would be 24. So this last guy would become just 24. So here is the derivative of this function with respect to x. So now let's do it again with respect to y. So let me once again copy and paste this thing. So let me make it black. And now I would like to take the derivative with respect to y. So my y is going to be a variable this time. And my x is going to be just a number. So if I want to take the derivative with respect to y, I'm going to get f sub y is going to equal to, let me see, log of x is just a number, so it stays the same, so I'm just going to get log of x here. The derivative of y would be just 1, so this would be just 1. The derivative of 3 to the y, so again my y here, this is a variable. So the derivative of 3 to the y would be, let me see, 3 to the y times log of 3. 3 to the y times log of 3. And as for the last guy, the derivative of negative 24x, well, because this term has no y in it, so its derivative would be just 0. So now here is my derivative with respect to y. And for the last part, I'd like to find f sub x of 1, 2. So once again, this is asking for the derivative of f with respect to x when my x is 1 and my y is 2. So I'm just going to look at my derivative with respect to x, which is this guy. And what I'm going to do is I'm just going to plug in the values for the value for x and y. So my x would be 1 and my y would be 2. And once I do that, what I'm going to get is, let me see, 1 over 1 times 2 plus 0 minus 24. And I'm going to get negative 22. So here is my answer for the last part. So basically, here is how we take the partial derivatives. We treat one variable as a variable and everything else as a constant.